Good night, Professor Juan Gonzalez. Today I'll present you a review of the methanol to olefin process, also called MTO. The article I used was a review of the methanol to olefins by C. Lee, published in 2025. My presentations will be divided in 6 parts. The first part is introductions, the second part is the methodology, the third part is the flow diagram, the fourth part is the results, the fifth part is the conclusions, and the finally part is the bibliographies. Okay, first, introduction. The MTO process, the MTO process converts methanol into lye, olefins, mainly ethylene and propylene. These are very important raw materials for the chemical industry since they are used to make plastic, fibers, and many derivatives. Traditionally, olefins are produced by steam cracking of petroleum fractions, but MTO is becoming too competitive because it can use different feedstocks such as coal, natural gas, and even methanol made from captured CO2. This makes the process not only economically relevant but also more sustainable. Second, methodology. The key of the MTO process is the catalysis. Cellulose, especially SAPO34, are used to direct the reaction toward high selectivity to olefins. The process begins by mixing the methanol with the steam, which reduces catalyst deactivation. Then the mixture is sent to a fixed bed or fixed bed reactor where methanol is converted into hydrocarbons. Finally, the reactor products go through a complex separation sections to isolate polymer grade, ethylene, and propylene. Okay, next is the flow diagram, and we can see the process. This diagram shows the main stage of MTO process. First, methanol and steam enter the system as feed. We can see in this part how methanol and the steam feed the process. Okay, then they go to the reactor. This can be a fluid bed reactor, where the methanol is converted into olefins. After the reactor, the effluent passes through catching and heat recovery, which cools the stream and removes water and impurities. It passes for here, and the water and impurities is for there. Okay, finally, the separation sections consist of a distillation train. The distillation train is for here, this. And, in there are the methaziner, the tenaziner, C2 splitter, the propanaziner, and C3 splitter, etc. We can see the names and the ubication in the down part for here, and we can see what means every letter in every figure there. Okay. These columns separate the products into methane, ethane, propane, and the most importantly, high purity ethylene and propylene. Ethylene and propylene. That is here. Ethylene and propylene is the exit. Okay. In the results, results. Okay. The article shows that MTO is already a mature and competitive process. For example, in China, large scale of MTO plants are in operation using coal-based methanol as feedstock. Compared with steam cracking, MTO can achieve similar or even lower production costs in a coal-rich regions. The use of SAPO34 catalyst allows very high selectivity reaction around 80% for light olefins. Ethylene and propylene yields are high enough to supply polymer grade materials. However, some limitations remain. Catalyst deactivation due to coke formation is still a major use recurring generation cycles. Also, the separation sections consume a significant amount of energy. Since cryogenic distillation is a required for high purity olefins. To address this, researchers are investigating new catalysis with higher stability and better pore structures, as well energy integration methods to reduce the load of refrigeration cycles. Overall, the analysis suggests that MTO is not only economically feasible but also a promising step toward decarbonizing the petrochemical industry when combined with methanol from renewable sources. Okay, conclusions. In conclusions, the methanol to olefins process is a strategic technology for producing light olefins. It diversifies feedstocks by using methanol from coal, natural gas, or CO2. It achieves high selectivity with CaPO34 catalysis, and it is already industrial competitive with steam cracking. Future research shall focus and on extending catalysis lifetime and reducing the energy uh, focus on the extended catalysis, reducing the energy demand of separations. If methanol can be produced sustainably, MTO will play an important role in building a greener petrochemical industry. And finally, we have the bibliographies of the article and the imagine I use in the methodology screen. Thanks for watching and listening.